Welcome to Data Analysis with Python. In this video, we're looking at data cleaning and pre-processing. Like I said already, in the data analysis process, right, the first thing you want to do is get your data from whatever source. And after getting that, the next thing you want to do is to clean the data up. You want to inspect the data and clean it up for, missing values, duplicated values, and things like that. That is why data cleaning and preprocessing is extremely important because if you don't do this, it can mess up your analysis at the end of the day. So you see, data cleaning is a critical step in the data analysis process. It involves identifying and correcting errors, inconsistency, and missing values in a data set. It is an essential step in the data analysis process for sure to ensure that the analysis results are accurate and unbiased. So if you want unbiased, accurate results, then data cleaning is really important for you. So that's the essence of this video. And as usual, right, I have I have this code sheet, the the data sets I'm using. You can find them if you check the description box. So even before you start, following the class, just go ahead and download all these things and open. You can even open the code sheet in your Jupyter notebook and then follow along. That's the best way to learn. Like I keep saying, the best way to learn anything that involves coding is to code. Don't just watch a long video, and then go. By the time you're done watching the video, you probably don't have any energy to even continue again. Okay, so you want to download all the materials following the link in the description now, and then follow step by step. Make sure you download the data sets. Here I'm using, of course, self-generated data sets and two data sets, supervisors data set and people data set. So those are the two data sets I'm using here right now for this data cleaning. All right, so let's go ahead and start the cleaning process. One of the things common, when you want to do data analysis is that the fact that there are some missing values. You can conduct a survey and then some people fill some parts and you don't fill some other parts and there are missing values. You have to have a strategy for dealing with such missing values. Or if you work for an organization, probably the organization they have a particular way by which they take care of such things, right? So handling missing values are common in data sets and can be caused by a variety of factors, such as data entry errors, sensor failures. If you are taking data with a sensor, it may fail at some point and then you don't have data for the period for which it failed. Or you can even have non-response in surveys. Like you conducted all the surveys, some people answered, maybe you have 50 questions and somebody answered 45 and left 5 for you. So you have to find a way of dealing with those missing values. Then Pandas provides several functions for handling missing values. So of course, how do you take care of missing values if you don't even know if they exist or not? And that's why the first thing you want to deal with is detecting missing values, right? And the special function to detect missing values using pandas is the is null function. I want to put that. I want to make I want to italicize it. All right. So to detect missing values in the pandas data frame, you can use the is null function. So the supervisors data set I'm using. Let me quickly introduce you to that. So if you see it here, these are the two new, apart from the other data set I've added before, these are the two new data sets I'm using now. Where is it? Supervisors. Okay, yeah, you have the supervisors data set, and there's also the people data set. So you want to download that right now so you can follow along. So going back here now, okay, yeah, let's quickly look at what the supervisor data set looks like from here. Okay, so you see, we have supervisors in a company, right? Their name, their gender, their age, the city, salary, and the number of staff working under them. And then, of course, you can see that there are some missing values right here. There are some missing values like this. Okay, so that's the data set we are using here. Now, we go back to what we have. So you want to detect the missing values. From the Excel sheet, you can already see there are missing values. Now, it's easy to see this one because you have just like 21 or 22 data points. But what if you have like 200,000 data points? It's difficult to know. So what you're doing here is to detect missing values in the pandas data frame, you can use the isNull function, isNull. So isNull helps you to know the number of missing values and where they are missing values and the number of those missing values, which I think is even more important, right? So of course, you cannot do anything in Pandas without first installing already, and then each time you open a session you need to import pandas. And once you do it once, you see I have it in almost every cell, because sometimes beginners have they forget to run to import it. So you just need to import it once. You don't have to keep importing it like I did here. But I just do it is to guard against people forgetting to import several steps away, and then they have a problem along the line. So you don't have to import more than once. That's all I'm saying. So import pandas are speedy, and then so here we are in line 3 now. We are reading a data set in Excel. That supervisor's data set I showed you. So, and since it's Excel, then you say DF. This DF can be anything. Well, because it's data frame, you can call it your name, you can call it whatever, anything that helps you to recognize it very easily. So we say DF equals PD dot read underscore Excel. So this read underscore Excel is a function inside of Panda with which you can open or read a data set in Excel format. Okay. So, and then this in line 5, we have a print there. So this print df is null. So that's the is null function. So df is null. So that will help you. It will uh it will show you a table where and show you some missing data where missing data are. And this print in line 7 that is blank is just to give space between the results you get here and the print we also have here. So this second print is going to show you the number of missing data missing values, altogether, which I think is more important than this, because if you have a very long data set, this line 5 doesn't help so much. So I run this now and you see what we get. Okay, so you can see we have 22 data set because counting starts from 0. So anywhere you see true, it means that the data at those points are missing, right? But I mean, I feel this may be really not so helpful if you have a very large data set. And that is why this line 9, the result it gives you. So this blank print is the one giving you this open space. Because if I comment this, all right, if I comment this and run, you see everything is joined together. So you don't know where, so it's difficult. It's not as easy to read. So, but that's why I want to put that blank print to give a space. So this line 9 now is summing up the number of null values in under each column. So for name now we have a missing name, and that is the name under the name in row 20, right? There's that name is missing. Gender, everybody's gender is available because it's false all the way, so it's not missing. Then we have one age missing, we have one city missing, we have three salaries missing, three staff missing, and the data types for okay, I mean, the data types for all these values missing is integer, as obviously shown there. So the is not function returns a data frame of the same shape as the input with true values where the values are missing and false values otherwise. So when the values are missing, you have true. When the values are not missing, you have false, right? And then, of course, the sum function is then used to count the number of missing values in each column. And that's what you have here like this. So then now we know that there are missing values. So if there are no missing values, then you don't have to worry yourself. You can go to another step of cleaning. Okay. So now we have recognized missing values in our supervisor's data set. So the next thing we want to do is we want to remove rows with missing values. And to remove rows with missing values in the Pandas data frame, you can use the drop NA. So it's more like drop not available, right? Drop NA function. So anything that is anywhere anything is missing, it's going to. So it means that all these rows where one name is missing, one age is missing, one city is missing, any such row, we are going to have everything deleted, right? So in that case, let's see. Probably, I think it's even very good to first of all see the data set itself, right? Yeah. So let's see the data set itself. I think that helps. Let me do this. Create a space up there, and I paste this. So I just want to see the data set. So I can just print. I can just even say DF. DF is neater, like we already know. Okay, so you see this. So now you can see that for real, all this NaN means that those information are missing. So this is the actual data set. So when you come here now, it's just showing you the ones missing or the one that is not missing. So you can already see that here because you have the data. All the data sets are just 22 data points. But if you have several, it's difficult to see everything. So at the end of the day, you still need to know the number of null values. So okay. So if your policy is to say anything that is missing, so you may have different policies around this. If your policy is to say anything that is missing should be deleted, so you can use drop NA. You can use drop NA. But if you're an HR person, you want to be careful to delete something. So you want to be sure. Probably you only delete when maybe when somebody leaves the company or something like that. So here, let's assume that we have all agreed that we need to drop anything that is not available. So this import pandas as PD is not necessary, like I said already. Then we are uploading this again. I keep doing this in case something has been done previously, so we can get back the original document, original data set. That's why I'm doing this line 3 because beyond that, it's really not necessary, right? So sometimes you might have done something previously, but then you want to work on the original data set. That's why I did this because these two lines are totally not necessary, if not to guarantee that in case something had happened before, we don't have to worry about it. Okay, so here we have GF drop. So the data frame now the new data frame will now be the old data frame where you have dropped all the not available values, and then you now print the new DF. So look at this now. If I do this, so you can see all the values that are missing are gone. So you see now we have 0, 1, 2, 3, 4, 5, 6 is missing, 7, 8, and 9 are missing, 10, 11, 12 are missing, 13, 14, 15, 16, 17, 18 is missing, 19 is there, 20 is missing, and 21. So those have been deleted now. Okay. So that's if you want to drop any value that is missing. So the drop any function removes all rows that contain at least one missing value. The resulting data frame will have fewer rows than the original data frame. So here we have 20 is gone, 18 is gone, uh okay, let me start again. 0, 1, 2, 3, 4, 5, 6 is gone. 7, 8, 9 are gone. 10, 11, 12 are gone. 13, 14, 15, 16, 17, 18 is gone. 19, 20 is gone. So we have 7 gone out of 22. So we have 14 left, 14, only 14 left. So now another thing we want to do is we want to replace missing values. So sometimes it's you don't have to delete any value that is missing. So you have to just replace. So to replace missing values in the pandas data frame, okay, I forgot to do what I've been doing what I did to the other one here. So I'll just put underscore before and underscore after, just like what we have in WhatsApp, and then you can have that italicized to show that it's something special. Okay. So here now we want to replace. And what is our replacement rule? So you have to decide how to replace what is missing. So and if for instance, maybe you're HR working with supervisors data set like that. So maybe you may need to you may need to make your research to say, oh, that name that is missing, who is it? So maybe you check your records and you find out that oh, that person is the missing name is actually Tunde. So you now say DF name. That's it. So under the column name, you now say the new DF name should now contain DF name dot fill NA. Any non-available value, replace it with Tunde because only one is missing. So replace it with Tunde. So maybe you did your research and you discovered that Tunde is the supervisor whose name is missing on that list, right? So you can deal with that. Okay, so you replace that with Tunde. But when it comes to gender, maybe after doing your research, you still don't know the gender of the person whose gender is missing because only one gender is missing. Then for age now, for age, so in fact, you see that for age and for salary and staff, all these are these are numbers, these are numbers, and of course, one of the things you would have done ahead of time is to find out if the data, you would have done your exploratory data analysis. We're going to talk about the exploratory data analysis along the line. So just watch out for that. So in exploratory data analysis, you want to see what kind of data column, what number of rows, number of columns, what kind of data you have. Is it object? Is it integer or something? Can you just like I said, based on the variables you already know, you can do calculations with integers and floats. Okay, so you see that age, salary, and staff are numbers. So what we are filling those things that are numbers, we are filling them with the average age of everybody every other person that is available. We are filling with the average age. For the city we don't know, we are filling with unknown city. Now, don't forget the operation I did here was to delete all the missing values. But here I want to replace missing values. So you can now see it is very necessary for me to do line three because I want to work with the original file. Now, what this deletion of the missing values I did here does not affect the original folder, original data set in my folder. It's only applicable here. So if I want to now save this, I can save it. I can now write it to maybe Excel, CSV, or JSON if I choose. So, but now if I call the original data set, I still have everything intact from the beginning, right? So that's why I'm calling this. I'm printing it to show you that everything is still intact here, because I've called it again. But if I don't call it, this DF is only going to operate on the previous work we had done, and then it won't make sense because we've deleted those values that are not available in the first place. So here, the name missing we replace with Tunde. The gender is unknown. The city is unknown, but age, salary, and staff, which are numbers, we replace with the mean, and that is df age dot mean, df salary dot mean, df staff dot mean, and then we now print the new df, and you see what we have. So I run this now. So we still have, so you need see the first one gives us the raw data sets. Uh, Maybe I shouldn't have bothered initially, but it's okay. Then here you now see that the name that was missing, number 20, is now you now have Tunde, and then the city that was not known is for Giorgio, and well, maybe I want to guess this like maybe somewhere in Italy, but we say it's unknown here. And then for the numbers, you see all the salaries. Anywhere you see the salaries looking like the same, then that is those are like average salary. So you can see this is an average salary because it's just the same you have here. So everywhere salary is missing, we are replaced with the average of the rest available. Then for the staff also, anywhere you see all this long number, 16 point something, 16 point something, that is the average of every other staff available. For age, same thing. Anywhere you have many values like 33.09, blah blah blah. So it's the average of whatever you have left. Okay. So you can delete uh unknown values, missing values, and you can replace them using whatever rule. Maybe you have done your research and you now know what is missing and all that. Okay, so we use the fill any. So the fill any function replaces missing values with a specified value or method. In this example, the missing values in the age and salary columns are replaced with the mean, age, and salary, while the missing values in the city column are replaced with the string unknown, like that. I think that's for both city and yeah, I think it's basically for city, right? For city and gender, yeah, city and gender. Okay, city. This is also unknown. We have a gender that is unknown. Okay, all the gender are known, so we don't bother. Okay. Now, another thing is handling duplicates. So we have dealt with missing values. So you identify missing values, then you can delete missing values or replace them. Now, how do we? So sometimes you have duplicates in a data set, and so if something is duplicated, it's going to affect. And if it is uh, wrongly duplicated, right? You know, sometimes you can have people with similar records, right? Maybe they have the same name and surname, and they are in the same location and everything, and all the data look exactly alike. So it's important to handle duplicate, but so you have to be sure when you have duplicated value data points like that, you have to be sure that it is actually correct or wrong, and then you decide what you want to do. So duplicate data can lead to biased or inaccurate analysis results. So Pandas provides functions for identifying and removing duplicates in a data frame. So the first thing, of course, is to identify duplicates. So to identify duplicate rows in a Pandas data frame, you can use the duplicated function. So again, I'm uploading the original file to make sure that it's I'm not what we had done before now is does not affect it. But if you want to keep working on the same thing, then you don't have to import the new you don't have to read the new file, the file we started working with, the supervisor's file. So import pandas as PD, which is not necessary, but maybe for newbies it's fine. So df this we bring the original file. So if we print to see the original file, then df duplicated tells us what we have duplicated. So if I run this, so it tells us the duplicated function returns a boolean series with true values when the row is duplicate of a previous row and false otherwise. So let's anywhere you see true, it means there's a duplicate. Now, for instance, look at this. We have true here. Number 14 is true. Number 21 is true. So it means number 14 is a duplicate of something before it, and number 21 is also a duplicate of something. So let's see. Number 14 is Pierre. So we have a Pierre here. Interestingly, we have like 3 or 4 pairs. So we have pair in 13, 14, and 15. So why is 14 saying that pair is a duplicate of somebody? So let's see. So how do you think it's a duplicate? So pair, male, 36, in Paris, the salary is 120,000. and the person has 26 staff under them. Then number 14, same peer, male, same age, Paris, 120,000, 26. Now that's why it's suspicious that, oh, this one has exactly the same record as the other one. But why is 15 not flagged as a duplicate? Because this peer now is male and the age is 36. It's possible they are based in Paris, same salary, but the number of staff under them is different. Of course, while that still requires some investigation, but Python will not flag it as a duplicate because at least one record is one information is different for that peer. So it won't take this one as peer, but maybe as the person in charge, you may just want to be sure that this is another peer because most of the data are matching. But number 14 is matching exactly with the first peer. So that's why it is flagged as a duplicate. Then you have Ying in 21 flagged as a duplicate too. Why? The first Ying is in 19. Ying female 27 in Beijing, 200 salary, 8.0 staff. The other Ying has exactly the same record. So once all the records are through across board, then it is flagged as a duplicate. So we see Pierre in 14 is duplicating Pierre in 13. Ying in 21 is duplicating Ying is in 19. So and that's why we have that. So now the next thing you want to do is you want to, of course, by all means, you want to remove duplicates. Once you confirmed that it's a duplicate, you just want to go ahead and remove that. Okay. So removing duplicates. So to remove duplicates in a pandas data frame, you can use the drop duplicates function, right? So again, I don't need this first line. So then I'm bringing this back again. I say df pd dot read excel. Then I drop duplicate. So those duplicates have been identified in 14 and 21. So this line 4 is going to remove all that. So we have the new data set without the duplicates. So if I run this now, you see that number 14 is no longer there. That PR in 14 is gone, and the Ying in 21 is also gone. So we have we have 19 data points now because we have deleted two. Okay, so the drop duplicate function removes all rows that are duplicates of previous ones. The resulting data frame will have fewer rows than the original data frame because we have deleted two here. Now, let's talk about some other inconsistencies. Handling inconsistencies. Inconsistencies in data can arise from data entry errors or different data sources. Pandas provides functions for identifying and correcting inconsistencies in a data frame. So for instance, maybe you are taking measurements, or somebody is in the UK, somebody is in the US, somebody is in Nigeria, and of course probably the person in Nigeria and the person in the UK, they have the same measuring the same measurements, the same way of measuring things, so to speak. And then the person in the US, the person in the US has a different way of measuring. So those are inconsistencies that you have to pay attention to as somebody handling data like that. So inconsistencies in data can arise from data entry errors. Okay, like I said. So maybe one way is maybe you want to rename columns. To rename columns in a Pandas data frame, you have to use the rename function. For instance, I bring the supervisor data set. Line 4 visualizes it. Line 6 gives a space. Can even close this up a bit. So maybe I want to rename a column, right? So I just say df equals df dot rename. So this dot rename is the key thing. And then columns. So column name, I want it to now be first name because it's just first name we have there. And instead of salary, I want it to now be earning. Okay. So of course you can already see the original thing in line 4. Then line 10 tells you what you now have after doing the renaming. So I run this now. So you see the two. So you see the first one. Name now becomes first name. Then what else? Salary becomes earning because that's the way we now want it. So you can have the rename like that. So as you can see, then we can also change data types. So sometimes you need to change data types. To change the data type of a column in a pandas data frame, you can use the as type function. For instance, now we have for the supervisor's data set, you can print the data types first of all, but then you now see that the age is supposed to be string, but maybe it's not a string. And then we now say df age in the age column, we want the data type to be string. We don't want to be able to do calculations with the age, so to speak, for whatever reason. So if I run this now, so you see the age here is float, so it means you can calculate with it. But the age here has been changed to an object because I now said whatever the age which was float before, I want it to be a string, right? That is just an object that you cannot do calculations with. That's what we have. So the as type function converts the data type of a column to the specified type. In this example, the age column is converted to a string because of this as type.htr here. Okay, so we can take it back also if you like. Now, another thing we want to do is we want to ensure correct data types is critical. Ensuring correct data types is critical for calculation and filtering. For instance, if you're working with a time series data set where you have dates and all of that, so you want some consistency, right? So here, this is a manually imputed data. I still use DF for it because I mean I'm just running through. So here, we have a data frame that is made from a dictionary, from a Python dictionary. So you have date 2025 May 1st, 2025, May 2nd, 2025. So I now have it as 2025 slash 04 slash 03. So you can see that these are inconsistent date formats. So the amount here you have 100, 250, 300, no problem with those. But here in line 8, we have convert string to date time with mixed formats. So because it has mixed format now, you want it to be in one format. So you just say PDF df date equals pd dot to date time is a function inside pandas to convert date into mixed format. Okay. I mean, convert string to datetime with mixed format, right? So, and then you now have convert numeric strings to integers. Now, to convert numeric strings to integers, now, that simply tells you that for the amount side, so because it was string before, you want to be able to do calculations with amount. So you have to convert the string to integers, and that's what we are doing here. So you just say pd dot to numeric. So you change to numeric, and then the amount now you can now do calculations with all that. So if I run this now, so you see all the date format that were in different formats now have become they are now in the same format, and the amounts now okay, maybe we should have checked just like we're able to check here, like we can see the transition of the of what we had like this. So okay, probably before we got here, let's see what we had, and then we need a blank print for spacing, right? So I click on this. So you see the data was object, the amount was also object before now. And of course, you can always, it's object because it is a string literally here. But by the time we change this now, we can bring this back and see the data types too for this new one. Okay. Um, I can bring it here. Let me do a blank print for spacing, blank print for spacing, and this goes. Yeah, so you see now date now is now in date time format, which is standard instead of being object before. Amount is now integer, so you can now do calculations with that amount column. So how about handling conversion errors? So sometimes uh, you need to handle conversion errors. Of course, after you do your date time, you also want to do any error that is available. You want to make it NaN to show that it's not available. It's like more, you want to treat it as a missing data. For instance, look at all these dates now, but you now have this fourth one, which is not following any of these other ones. All right. So if by doing this line 10 now, so to show you that some of those things are missing. So we have this now. Um, okay. So it just automatically takes it up to be um okay, let me change something. My plan was to do something different. Okay, that's not working because it's unknown. So what this was supposed to do was to tell us any invalid values will become NaN. So it's okay. What if I just do 2025? Let's see what happens. Okay, so now it just takes it to the the closest thing possible. Okay, so that works. So we move on to cleaning text columns. Now, some text columns can be problematic, so you want to clean them up too for the sake of consistency. Here you are cleaning your data and you are pre-processing it for the analysis. We have not even started analysis right now. You just want to clean it up for the analysis you're interested in. So cleaning text columns. So text data often comes with extra spaces, inconsistent formats, or unwanted characters. Look at this, for instance. This is self-made data set from a data frame from a Python dictionary. So you have products, apple. So you see the apple, before the apple starts, we have space. After the apple, we have space. Banana. Okay, that's fine. The other banana. So you see banana here, banana here. This one starts with capital, this one starts with small. That's inconsistent. Grape and space in between. And usually anything you have inside quotation is going to be outputted exactly that way. Okay. So all these fruits, the category fruits, everything looks okay. So I'm printing this so you can see what it looks like. So here, what we want to do is we want to strip white space. What you have white space is all the space before the apple and after the apple and after the grape too. So when you do this line 10, all this white space will be gone, and then we have the normal thing. Then the next thing is we now want to, okay, this print is blank, right? So here I want to replace the small letter banana with big letter banana, then all the small letter apple with big letter apple, that's first letter. So if I do this in one blow, so see the original thing. We have apple, banana. So you see the apple that has been pushed forward like this because of the way it is. So the apple has been pushed forward a lot because of the space. And then we have uh banana. So and that seems to be affecting the two bananas, right? And then we have grape. So you can see the grape has some space in front. But by the time we take care of the white space, so the apple is centered, the two bananas are centered, the grape is also like centered, and then the category side is fine. But we go further to replace all these apple starting with small letter A with big letter A, banana starting with small letter A with big letter B. And so the grape also, you can see there's no space in front of it like before. So you can also do that cleaning up. Now it may look like it's not necessary, but it's helpful for the sake of consistency. Okay. Now, how about standardizing column names? So, consistent column names make analysis smoother and reduce errors in later steps, right? So, for instance, so if you want your column names to be maybe in lowercase, and then you want to strip, you want to remove all the white spaces and everything. So, you can do this using line one and this line one, then line two just helps you to visualize. So, if you do this now, you see product category. Before now, the product category was capital, capital. If you don't want it to be capital, capital, we can do it this way. All right. Or if it was smaller, you want it to be upper. So you can just change this lower to upper, and then you have what you need to have. Okay. Now let's talk about replacing values. Of course, I've done demonstrated how to replace values up here. So this is just like another emphasis. But since that was for the self-made data set, now I'm using an Excel data set now for replacing values. So we have the original data set now, and maybe the city for this in the city column, I want to replace Gainesville with Knoxville. Maybe we transferred one of the staff is transferred from Gainesville, Florida to Knoxville, Tennessee, and then we can do this. So if you run this now, so you see up here we had somebody in Gainesville. Brian, number 3, was in Gainesville, and Brian has now been transferred to Knoxville. So you can replace whatever you want to replace by making this kind of comment, right? So replacing values. So now we go to something else, which is about handling outliers. I think, yeah, okay. After handling, we'll do standardization of data. All right. So that's all these are part of the process. So handling outliers now. Outliers are extreme values that can skew analysis results. Pandas provides several functions for identifying and handling outliers. So the first thing you want to do is to identify the outliers. So to identify outliers in a Pandas data frame, you can use descriptive statistics and visualization tools such as box plots. We're going to talk about box plots as we move on later. But for now, we are using describe, which is one of the useful tools for visualize for uh, exploratory data analysis, which I'm going to talk about in a later video. So here now, so we have the same people data set, and then want to do so the people data set. I think this is the first time we are mounting it, and then want to describe what that looks like, right? So I run this now. So you see the people data set. Okay, I think it's very important to also see the data set itself for okay, after mounting it in line 3, I can now call it in line 5 print df so we can see the original thing. So let me put a blank print to create space in between. So I run this now. So look at what we have. So this is the original data set. This okay, this is another data set now, people data set, not as many as, so it has less information compared to the supervisor's data set. So the supervisor's data set is an extension of this people data set, right? So now look at what is going to happen here. Should I even use these people? I think it's better to use the supervisor's data set still for consistency. Or would there be a reason for this? So let me just do supervisors. Yeah, it's better to use the supervisors for consistency's sake. Yes. So this is the supervisor's data set. All right. What that normal thing we have always been seeing. The original one without, so that's why I mounted it again so you can take the original one. Okay, so now see what the describe is doing for you. It's showing you a statistical distribution of what you have for the numerical aspects alone. Okay. Um, so for the numerical aspects, now those are age, salary, and staff. So this tells you have 21 age, meaning that for salary now 19, meaning that two salaries missing, staff 19, meaning that two staff missing, then mean. So this tells you the average, the mean age of everybody in the company of will be is 33.09, blah blah blah. The average salary is 102,768 point something something. The average number of staff that under each supervisor is 16.78. The standard deviations are given. The minimum age. Now, we want to see outliers, right? The minimum age here is 18, right? Which is fine because you don't expect anybody younger than 18 to be in a company working, right? So to speak, except they are on a special. So if you have somebody less than 18, you want to really investigate to see what's happening. Then for salary, you have the minimum salary anybody earns is 61. Oh, okay. The minimum salary anybody earns is 200. You might want to wonder why is this person earning this low? You may need to investigate because that's rare compared to other salaries. If the average salary is 102,768, why is somebody earning 200, just 200? Okay. The minimum number of staff anybody has is eight. Then 25, you have the 25 percentile. So one key thing you are looking for is you are looking for outliers, especially the minimum and maximum. Now, somebody is 105 years old. Would that be a mistake? So you should be curious as you're analyzing this data. Is it a mistake that somebody is 105 years old in a company? Then we're talking about the salary. Okay, somebody's earning 230,000. Could it be that this person founded the company and the person is living very long? You don't know, so you want to find out for sure. And the number of staff under this 105-year-old person is 34. How is the person managing to do that? So those are investigations you want to do. So clearly, having an age of 105 is a lot. So if you can do your investigation and discover that, oh, it's a mistake, maybe the person is actually 51 and it was a mistake that made it to be 105. Or it may really be that that's the founder who is still alive, who owns the business. All right. So, but then by standard, right, sometimes you want to take care of outliers. You want to make sure anything below a particular threshold or above a particular threshold is beaten into a given range, right? So the describe function provides descriptive statistics of the data frame, including the mean, standard deviation, and quartiles. So the box plot, okay, we're going to talk about box plot later, right? We'll talk about it under data visualization. And then how do you handle outliers? A very good way to handle outliers is what you call trimming or Windsorization. So to handle outliers in a pandas data frame, you can use various methods such as Windsorization or trimming. So this involves a little bit of some of statistics or mathematics, so to speak. So here we mount the original supervisor data set. Then we have what we call the interquartile range. In fact, the interquartile range is this 25 percentile you have here. So the 25 percentile, that means that the oldest person among the youngest 25% of people is 24 years. So then when you talk about the 58%, a 30-year-old person is older than 50% of the company. This is used for exams a lot, especially like exams like GRE, IELTS. So maybe your results show that you are in the 75th percentile, meaning that of 75% people, uh, the bottom 75% people, you are ahead of them. That's the kind of thing that says to us. Okay. So in visualization, we need the 25 percentile. That's why the quantile is 0.25. We need the Q3, that's the third quartile. The Q1 is first quartile. Q3 is the third quartile. That's the 75 percentile. That's uh the this age 34 is older than 75% of people in the bottom 75% of the people in the company. And we now need an interquartile range. That's the difference between the third quartile and the first quartile. That's the interquartile range. All right. And of course, I've used this printing something very well to tell us all those information. Then we now have set a lower bound. So what we are doing here is that anything below a particular value and above a particular value, we are going to beat it into shape, so to speak. So that's necessary sometimes, especially if you don't want that, because this 105 is really an outlier and it can affect your analysis. So you want to beat it into a particular rate to make sense. Okay. So you have the lower bound, which is Q1 minus 1.5 times the interquartile range, which we have got here at the difference of third quartile minus and first quartile. Then upper bound is Q3, the third quartile plus 1.5 times the interquartile range. So that's the standard procedure if you are using trimming or Windsorization. Then if you do all this, you are going to get all these results. So we have the data like that. So you see that the first quartile is 24.0, which of course that aligns with the 25 percentile, like I said, 24. Then the third quartile, of course, is 34 as you expect. So the interquartile range, so the first quartile is 24.0 and the third quartile is 34. We are focusing on age because we discovered that somebody is outrageously old, compared to the rest of the people. That's this Ayumi person who is 105. Interestingly, it's known that Japanese people they grow very old. I mean, they have some of the longest what is it called now? Living they live so long. I think I've forgotten the word for that now. Okay. All right. So the first quartile is 24.0 and the third quartile is 34.0. So the interquartile range is the difference between these two. So with that interquartile range, now we now get the lower bound to be 9.0 and the upper bound is 49.0. So what that simply means is that anybody below 9.0 will be, so if there's anybody below 9.0, maybe the business owner has a grandchild who is below 9, who is also on the company's payroll. So you may want to investigate that. Why is somebody less than 9 years old here? So maybe you have a 5-year-old child there. So what this is going to do now is now to say that person that is 5-year old is also automatically going to be assigned 9, and anybody above 49 is automatically going to be assigned 49. So you can now say, assuming that was 105 is now 49 based on trimming or winsorization. So which is the standard procedure, sometimes so we can have more reliable analysis, because that one outlier can skew the whole data in a way that may not give us a reliable result. All right. So in this example, the interquartile range method is used to identify extreme values outside the lower and upper bounds. The clip function is then used to replace the extreme values with the corresponding lower or upper bound. All right, so we go to another section which talks about standardizing data. So there are two ways of standardizing data. We have scaling and normalizing. To scale data in a Pandas data frame, you can use the scale function from the scikit-learn preprocessing module. Scikit-learn is very good for machine learning. So I suspect that along the line, after talking about data analysis, I'm going to move to data science. Maybe I'll go to SQL before going to data science or something. Let's see how we move, right? So the scale function scales the values of a column to a mean of 0 and a standard deviation of 1 following this equation. So you have z equals x minus b over sigma. This is a statistical thing, standard, right? So you have standardizing data. So where z is the standardized value, x is the original value of the variable, u is the mean of the variable, and sigma is the standard deviation of the variable. So here we are standardizing. So imagine that. So pandas, we don't have to import it, but it's here just for to be sure. Then from sklearn preprocessing, we import scale because we want to use that scale thing. So we bring the dataset supervisors now. So I'm printing it to see, so for you to see the original. Then I'm having a blank so we can have a space between that. So we want to scale the age. So it means we want to standardize the age like that, following this formula, you know. So that standardization may be useful sometimes for analysis. So if I run this now, all right, so it gives me, so if you look at the age column now, so these are the original ages, but according to the scaling now, these are the Z values of the ages, which may be useful for analysis, especially in machine learning. Of course, here you are just talking about data analysis, but you need to understand this. So we may also want to scale the salary. So you see here, I'm not bringing the PD again. I'm not also bringing this stuff because the DF we used last is what I want to use. So now I also want to scale the salary. So I run this now. So you have the age was scaled. So since I didn't import the data set afresh, so the age was scaled and the salary is also scaled now. So they are now standardized. Okay. So the scale function scales the values of a column to have a mean of 0 and a standard deviation of 1. In this example, the age column is standardized. In fact, both the age and salary columns are standardized. In this example, the age and salary salary columns are standardized. That's what I'm doing there. Okay. Now, normalizing data. So we have talked about scaling data. So in scaling data, you are making the data in such a way that it is normally distributed. It is normal distribution where you have mean of 0 and standard deviation of 1 for those who know the statistics. Now, normalizing data is a bit different from scaling because normalization is a process of standardizing data to have values within a specific range. Maybe you want all your data to be between 0 and 1 because to deal with outliers. So you may need to do that. So the min max normalization transforms the data to have values between 0 and 1. And following the equation, X norm, the normalized data will now be the data itself minus the minimum data in the set all over the maximum minus the minimum. So by doing this, you just beat down all the data into bit to fall within 0 and 1, where X norm is the normalized value of X. X is the original value of the variable. X min is the minimum value of the variable. X max is the maximum value of the variable. So let's say now I want to normalize both the age and salary columns, right? To make sure they fall between 0 and 1. So this is necessary to handle outliers, like I said. All right. So now I bring the original data, the supervisor's data, then I read it, I visualize, I create some space between it and the next result. So here, now I'm doing everything at once. So I'm dropping all the duplicates on this data set. I'm dropping all the duplicates. I'm dropping all the not available values. That's what I've decided to do. I drop duplicates. I drop anything that is not available. That's what I've chosen to do. Then age and salary, I want them to fall between 0 and 1. Then I can now visualize. So if I run this now, you see all that. So you see, at first we had 0 to 21. So that's 22 data points, right? And then now anything that is missing is deleted. And then you see the age and salary are between 0 and 1. So none is less than 0 and none is bigger than 1 for both age and salary because we have chosen to normalize the data. So you have scaling, which makes the data normally distributed, and you have normalization, which makes the data fall between a given range. If I want it to fall between 0 and 2, it's also possible, or between 1 and 2, that's possible, but usually it's to fall between 0 and 1. So the normalize function scales the values of a column to have a unit norm, which means that the sum of the squares of the values is 1. In this example, the age and salary columns are normalized. So that you can normalize data like I said. So here now this last data frame we have done now based on this cell, this output 27 now, so now I want to write that to a data. I want to write that to Excel, or you can choose to write it to JSON or CSV, anything you like. So I want to write it to Excel now. So maybe it's like you have done your cleaning and you now want to write it out. Of course, I'm not bothering about doing the index again, which we can do. But I mean, once you are done, you're still going to do things like feature engineering and everything. But once everything is set and you have done what you want to do, you can now save it so that it will be different from the original data set. By the way, I'm saving this new data now. I'm saving it to Excel and I'm calling it a standardized supervisors record. So by the way, we don't already have that here. So this is supervisors, but there's nothing like standardized supervisors record. If you check, there's nothing like that in this folder. So watch out. By the time I run that now, it will automatically be created in this folder because everything we are working with is in that folder. So watch, I just click it, and once there's no error, it just gives me 28. That means the Excel sheet is automatically created. So if you come back here now, you find standardized supervisors record, which was just created 3:09 a.m. Just the same. This one just changed to 3:10, right? So I just have this now. So you see, you have the data set. So you see, the indexing doesn't even really matter. But if you want the index to show, you can always make sure of that, right? So now this is now like my cleaned and pre-processed data. So I can now use this for any analysis I want to do. Of course, there are other things you may want to do, like you may want to do feature engineering and all that. Um, okay. I think normally I should have even done exploratory data analysis before this, but it's fine. It's okay. Um, that should have come before this somehow. So let's see how that goes. So yeah. So we come to the end of this video. You want to tell me how helpful it is for you. Of course, we can see that which you have created. Now we can now read it again and see what it is like. So you see, this is what you have in that place now. So you see, it has done the numbering normally now. So this is the clean sheet you have to now process. Okay, that's what you have to process right now. Okay, so let me know in the comment section how helpful this video is for you. And if you want me, if there's something, maybe you want a data to be analyzed or you want me to make mention of something, feel free to let me know in the comment section. I may be able to find time to do that. If you have subscribed to the channel, thank you. If you have not, please go ahead and do that. And don't forget to hit the notification bell so you can always get alerted each time a new video is released. All right. So don't forget to like and share so that more people can have access to this great content. Till I come your way again, keep doing data right. Bye.